My name is Rajiv Jain. I'm a product manager with Alexa Voice Service at Amazon. Today, it's my real pleasure to be here with you today and talk to you about an exciting new solution that we're building for you to put Alexa in a new category of devices. Joining me today are my colleagues. Please introduce yourself.
My name is Philippe Lanton. I'm a solutions architect for the Alexa voice service. So I help partners integrate Alexa into their devices.
And my name is Adam Stevens. I'm a development manager that helped build the backend for the solution that we'll be talking today.
All right. Before we start, I'm going to ask a few questions, and please raise your hands. How many of you have at least one Alexa product in your home? Great. How many of you are Alexa developers? Maybe you've tried building a skill, maybe a product at home, maybe at work. Great. And anybody in the audience who's familiar with the AVS device SDK, that's the open source code that's on GitHub. You can put that on your Raspberry Pi. I see one. OK, a couple of people in the audience. All right. Thank you. So one of the key themes here at reInvent is reimagination. And today we are going to talk to you about how we reimagined how you, as device makers, put Alexa in your products. What does that mean to you in terms of experience? And what does that mean to you in terms of adding and differentiating products that you build and offer to your customers? So that's what we're going to cover in the session today. Agenda-wise, today I'm going to talk more about how we at Amazon, we think about the smart home opportunity, what it means to build Alexa into smart home products. Philip is going to talk to you on how you take the solutions that we're building and how you can go to market very, very quickly with those solutions. And then Adam will get into the technical aspects of the product. The goal of the session today is to have you walk out of this session knowing exactly what's the value proposition of this new solution that we call AVS integration for AWS IoT Core, a big name. And if you are interested in getting started, how you get started with this today. We want to wrap up this session in maybe 45 to 50 minutes. We won't be doing any Q&A from the stage, but we'll be available in the back to take any questions that you may have on a one-on-one basis. So very quickly, what do we say what do we mean when we talk about the smart home? Smart home, as you see, there are a lot of big numbers on the screen. There are about 91 million homes in the US and Europe that are connected. There are billions and billions of devices that are connected today, and that's almost doubling in the next couple of years. And when you look at the revenue numbers, $50 billion of projected revenue opportunity in a couple of years, this is massive. And this is certainly something that we see on Amazon.com. The revenue that we see from this category of devices is almost growing at 90 to 95% year over year. So big, massive opportunity. And when you think about Alexa, what does Alexa do in smart home? We see Alexa in lots of different categories of devices. Obvious ones that everybody knows about is lighting. You have companies like Philips Hue, TP-Link doing a lot of innovation in smart lighting space. You see locks, August, and other lock companies, Ring, a lot of cameras, appliances. So there are just a lot of device types where Alexa is getting built into these devices, and our device makers and our customers are innovating. What do you do? What does this mean, putting Alexa in your product? We see two different types of integrations. First is what we call Alexa built-in. So think of these devices as devices that have mics and speakers. These are the devices you can talk to. You can say, Alexa, play music. Alexa, what's the weather? And these devices respond back. These devices talk back to you. We enable our partners, such as Bose and Sonos, to put this experience in their devices and go to market. This type of integration is called Alexa built-in. Second type of integration is called Alexa Smart Home Skill. So think of these as connected devices that you control by talking to a companion device. An example would be Philips Hue. So this is an integration where you develop a skill that is controlled by talking to an Alexa endpoint in your home. So these are accessory devices, if you will. And we have seen about about 85,000 different product SKUs with Alexa smart home skills, and thousands of SKUs with the Alexa built-in. And then we have partners who are doing both in the same product. An example would be Ecobee. When Ecobee did their first thermostat, that was works with Alexa product. That's where they had a skill, and a user would have to talk to Echo endpoint, like Echo or Echo Dot, in their home, and then control that thermostat. Great experience, and for the next generation, Ecobee built in mics and speakers into their Ecobee 4 thermostat. And all of a sudden, the users did not need to have two Alexa products in the living room. They could get the same experience of Echo on their Ecobee 4 thermostat. And that's been a really, really good experience. So you may ask, why isn't every smart home device an Alexa built-in? And this is a really, really big question. If we understand why is the case, what are the problems, and we can do something about it, this opens up this $50 billion devices opportunity that we talked about. When we talk to our customers, when we talk to our partners, we heard three big problems. Why is Alexa not built into every single smart home device? First one was about how you build your smart home devices today. These smart home devices tend to have very limited amount of compute and memory. When I say compute, think of these as a microcontroller, not a microprocessor. Microprocessor is something that you see in your smartphones. Microcontroller is something that you may see in your smart light switch. The amount of processing that's available on a microcontroller is tiny compared to the processing that's available in your smartphone. You build these devices with very, very little RAM. A typical phone may have 4 gig or 2 gig worth of RAM. In a smart home device, you may see 100 KB, maybe up to 1 MB RAM. So this is order of magnitude difference in terms of the capabilities that you put in versus what Alexa experience today requires for to function. Higher component costs results higher degree of complexity results in higher product cost. And this is really the kickers. So think about it. If you are thinking, let's say, putting Alexa built-in into a smart switch, and because of the degree of components that are required, that the MSRP, the retail price of that may go up significantly. If you, as a customer, you're buying smart switches for your home, and let's say you have 25 to 30 devices, and each switch costs $200, that's $6,000. That's a lot of money. Nobody will spend this kind of money, or very few people will. So the idea is that how do we bring down the cost of building these devices so that customers can do more and more, buy more and more of these devices and find more utility out of these. And third is complexity. And there are multiple degrees of complexity. First is how you think about the skill set that's needed to build these devices. The moment I say, hey, you need Linux and you need to do C++, and I'm going to give you 50 MB or 100 MB library, you need a very different engineering skill set than what's available with our smart home customers today. Smart home customers say, I don't want a Linux, I want a free RTOS. I don't want hundreds of MBs of code, I want a few KB, or maybe a few hundred KB, right? And once you build it, what does it mean to maintain these? Alexa is an evolving experience. We keep on launching new functionality. You may have to add new features and functionalities to your device. So this translates into high fixed cost of creating these products and then maintaining these products over a period of time. So going back to the question, how do I cost effectively build Alexa into my smart home devices? And when we reimagined the experience, we said, hey, maybe we can offload all the compute and complexity from the device into the cloud. And that's exactly what we did. And this is the new feature in AWS IoT Core. It's called Alexa Voice Service Integration for AWS IoT. And with this, we are offloading a lot of compute and complexity that used to be on the device into a cloud. and we are exposing that through a simplified set of APIs through AWS IoT. So think of this. You just connect to AWS IoT and over an MQTT topic, and you send and receive audio messages to Alexa reserved topic. And we do this at a very, very low latency. And Adam's going to cover how we manage to reduce latency and build an amazing experience so that you can offer these experiences to your customers. So what are the key benefits? First is lower cost. And this is a significant benefit. We have taken an order of magnitude, or maybe 2 orders of magnitude reduction in memory. From 100 to 50 MB RAM, you go down to 1. And this 1 MB includes the RTOS. It includes the application, the Alexa application. It includes all the audio libraries. It's an end-to-end experience in less than 1 MB. You can create far-field experiences with Alexa. Low cost means you can make Alexa more ambient. You can put Alexa in devices where it was not feasible to put Alexa so far. And that's really, really interesting. And it opens up new areas and opportunities for you. You simplify firmware development. You go from 50 to 100 MB code down to 350 KB application code, and maybe another 400 to 500 KB in audio code. From 50 MB down to 1 MB, less time and cost to develop, less time and cost to maintain. And that's huge. And then last but not the least, and Philip's going to cover this in a lot of details, we've worked with our chip partners, NXP, Qualcomm, and many others, to be able to give you production-ready kits, which you can get started today. Some of our customers have taken these kits and have gone to market in 4 to 6 months. And that is really, really interesting. So as I talked a little earlier, how you get started. You create a device, add mics and speakers. If you already have connected devices, you already have Wi-Fi. All it is you add a couple of mics, speakers, and maybe upgrade the processing and memory. And that's usually incremental cost that's really, really easy to absorb. You connect to AWS IoT Core using MQTT, and then Alexa is available as a reserved topic on that MQTT. You send audio over MQTT and receive audio over MQTT. And once IoT receives that, it hands it over to Alexa. Think of this as a virtual appliance that's running in the cloud, and we take it over from there, and all of the complexity, and we're going to cover that in details, is managed and handled for you. So what you see on this slide is our current existing AVS device SDK. This is a solution where it takes about 50 to 100 MB RAM, depending on what you end up using. This is available as open source code on GitHub. You can go download that today. You can build your devices, Raspberry Pi, within 2 hours, you can have a built-in experience. And a lot of our device makers have used it and taken commercial products to market. I'm not going to cover this in too much details today. We had a couple of workshops where we talked about it. But the way you think about this, the left-hand side blocks are the audio blocks. Wake word, how you think about the far-field noise pickup. And then the right-hand side blocks are think of these as logic blocks. And we took these logic blocks and we moved them from device into the cloud with the new feature. And that's really interesting, and we're going to talk a lot more about it later, but I'll just give one case in point. When you think of playing music through Alexa, Alexa music can come from multiple music service providers: Amazon Music, iHeartRadio, Pandora, TuneIn. All of these providers have different codecs, different formats, and as a device maker, you need to implement all of these codecs and formats on your device. With this new feature, we are able to transcode all this audio into the cloud, simplify it for you by sending you a stream in Opus. So as a device maker, now you don't have to worry about 6 or 7 different codecs. You just need to implement Opus on your device. And there are a lot of other things that Adam's going to cover in more details. So what does this mean? What do you do with all of this functionality? So think of this as, when you think of Alexa experience, think of 2 types of interactions. One is what we call push to talk. voice-enabled remote control. This is the device that you actuate by touching the device. If that's all you're doing, you can do that in 500 KB RAM on an M4 class processor. And that's really, really cool. Think these are super low-cost chips. And all you need to do is connect to AWS IoT Core. AWS provides C SDKs for MQTT. You need to get Opus codec on your device. Again, that's a library that's available in open source. You need to be able to do some audio buffering, and you need to be able to authenticate your users using LWA, login with Amazon. And that's it. And Adam will cover a lot more in details. On the other hand, if you want to create devices that are far field, where the devices can hear you 15 to 20 feet away, where even if the music is playing, you can barge in. You can talk over music, and the device will still hear you. For that, you need audio algorithms. Alexa wake word, front end, and a lot of different types of algorithms. You can do that in two ways. You can just bolt on an external DSP that encapsulates these algorithms, and one of our chip maker partners that we are going to talk about has done that. Or you can take an ARM M7. So instead of M4, you upgrade your processor and you go to an M7, and you can do these audio algorithms on a single chip. And we are going to cover both later on. What does this mean? What can you do with this? So what you see on this slide is a comparison of different Alexa device solutions. AVS over AWS IoT Core is the first column. The AVS Device SDK, that's the product on GitHub, that's the middle column. And then the Smart Screen SDK, this is the SDK we announced about 2 weeks ago, is the last column. And you can see that depending on your use cases and the experiences that you want to create, we provide you with a lot of solutions that you can use to create the experiences that you want. If you want to create interactive experiences on TVs, the Smart Screen SDK is a phenomenal solution that helps you create these experiences, interactive experiences on TV. What we are talking about today is the experience for the category of devices. Think of these as light switches or smart plugs or coffee makers, or appliances. This is what we call a voice-forward experience. These devices let you control other devices. You can say, Alexa, what's the weather, or turn on my lights, make my coffee. And these devices are usually optimized for speech rather than music playback. And the reason for that is these devices may have tiny surface area. Speaker takes a lot of volume. The bigger the speaker, the better the volume. There are a lot of companies who do a lot of optimization around it. And if you want to create a great speaker experience, that's where you use the AVS Device SDK. So the features that are available on the AVS for AWS IoT Core are Alexa skills. You can use any of our skills. Dialogues, you can say, Alexa, what's the time? Alerts, Alexa, set a timer for 10 minutes, or remind me that pasta will be ready in 10 minutes. Announcements, Alexa, dinner's ready. And music. And now I'm going to invite Philip to talk more about how you can quickly go to market with these devices. Philip?
Thank you. Thank you, Rajiv. So now you've made the decision to build your device based on AIA. What's the first step? Well, the first step is choosing one of our partners that developed a development kit that implemented the AIA protocol. And let's go over a few that are available today. So this is one by NXP. We actually gave 2 workshops at this reInvent with this kit, and that allowed all the attendees to build a fully working solution end-to-end as part of the workshop. And one of the things that's really compelling about this solution here is the dev kit is kind of very elegant. It's about the size of 2 fingers. It's got a speaker. It's got 3 microphones. It has the NXP RT106A ARM processor, which is a very capable processor that not only can run AIA, It can also do additional functions that you might want to do on your device, such as control light switches or other smart home equipment. It runs Amazon FreeRTOS, which is FreeRTOS is the OS that basically drives microcontrollers, and it's an operating system that Amazon has sponsored since 2017 to enable faster development and more elegant development, especially for applications using AWS IoT. And so let's say you choose this kit. NXP will give you the full schematics of this particular kit, in addition to furnish the Alexa wake word and the audio front-end algorithms to perform noise cancellation, beamforming, which is important for picking up voice across the room, as well as providing a good experience with microphones by tuning for proper audio. And one of the things is, like on this kit, it's 3 mics. You may well implement a solution that has 2 microphones, and you could tune the audio front-end algorithms for those configurations. So if you're interested in obtaining this kit, there's a link at the bottom, and I'll provide another slide that you can also take a picture of that will have the link, and get that from NXP directly. So let's go take a look at another kit. This one is by Qualcomm. This one is different. It is meant to use one of the Qualcomm SoCs that actually offers Wi-Fi as part of the chip. So what's interesting here is the M4 chip that powers the AIA solution also offers Wi-Fi capability on it. So it's a completely integrated solution. The kit from NXP actually uses a separate Cypress chip for Wi-Fi, and this one actually integrates it directly on the SoC, on the M4 processor. It is coupled with a Connexent, so Qualcomm partnered with Connexent to offer the voice capability, which would be a DSP by Connexent that allows you to run the audio front-end algorithms as well as the Alexa wake word. Now, you might ask, why can't I do the wake word and front-end algorithms on the M4? And the reason is it's not quite powerful enough to do that. And while there's some development going on to enable that going forward, for now, having a separate DSP in this solution is what was recommended. And one of the things to understand is that, let's say if you just wanted to do a touch or tap-enabled experience with no wake word, and just what we call near field, which would be maybe 1 to 2 feet away, you do not need the Connexent. You could just implement a solution based on a single microphone and the M4 base. And again, if you're interested in obtaining this kit, you can go on the bottom link and order it from Qualcomm. So let's take a case study. So iDevices was our first partner to implement AIA. They chose the solution by NXP. And one of the I would say items that was easier for iDevices to move on AIA was that they were already using AWS IoT, so they were familiar with AWS already. They had a fleet of devices already that were using FreeRTOS. And so when they found out about AIA and said, hey, I can just add voice to my existing products and just use the same kind of architecture, and I don't have to retrain my engineers to actually learn a new operating system that would be Linux or Android, they say, hey, we're all in. And so not only did iDevices do this with AIA, they also chose to implement other AWS IoT products, which are device management. And this one's a huge benefit, because let's say you develop a product such as this one, and of course all these products run firmware that you need to update every once in a while for new features, and maybe changes throughout the life cycle of the product. It's very important to understand that you need to have a way to push firmware updates and know how your fleet is doing of devices. And it's one of the things that iDevices took to heart, and they adopted AWS IoT device management to actually manage the firmware of the product. So they can do things like push out firmwares using the abilities of device management, and they can do things like track the deployment of their new firmware across a fleet of devices, target specific devices if they want a beta test of certain features. So it provides you the ability to also do some analytics and see how your devices are doing out there. So one of the key things that's important about connected devices is how do you know that you're not having, let's say you release new firmware, but maybe the Wi-Fi driver needed a little bit of work because now you're seeing more devices being disconnected. You want to be alerted as soon as that happens, and that's why you use services like AWS IoT and analytics to actually know, make sure your fleet's doing well, and you can react quickly to any events that happen. So here's a quick link to our dev kits, a picture opportunity here, and there are more on the way that we'll be announcing in the next year or so. And one thing I do want to mention is the pricing structure for AWS IoT for Alexa, for AIA, is all the traffic that travels on that reserved topic for Alexa is not metered. This means you will not be charged for the traffic that travels through that topic. So again, when you speak with Alexa or you're playing music, all the traffic that travels, all those MQTT messages are not charged on this topic. So the AWS IoT core benefits, obviously, a secure connection to the cloud. So every single device has a unique certificate. And Adam will go into a little bit of detail as to how we make sure to have encryption for voice on top of that. We can easily route events with AWS IoT. It's one of the reasons we chose to implement our AIA solution. And also, let's say if you want to have a good way to control your devices and know when they become online and offline, it enables us to properly track state. And of course, the integration with additional AWS services is really helpful. So as part of a standard solution, you start with Amazon FreeRTOS running on a microcontroller. And you implement AWS IoT Core. And again, this is where going with a solution by one of our partners will help you out, because they will provide actually firmware builds and the source code necessary for you to get a head start. And of course, Alexa Voice Service is what we offer that will ultimately offer the Alexa functionality. So now I'm going to pass it to Adam for our deep dive.
Thank you, sir. Thank you, Philippe. All right, technical deep dive. I'm going to try and cover 3 things in the next couple of minutes. What AIA did to enable these MCU-type devices, the implications of what we did, and if you wanted to get started with a dev kit, or if you wanted to get started with your own client, what are the components there and how do you do it? So that button. All right, so you've seen something very similar to what's on the screen right now. On the left is what you see for a traditional Alexa Voice Services device. All of those blue boxes are components or libraries you might pull from the AVS SDK, or you might write yourself to interact with the Alexa Voice Service APIs. So quick show of hands, who in the audience has actually interacted with the Alexa Voice Service APIs? Anybody? Done a demo, done a workshop here at reInvent before, so a couple of people. So the Alexa Voice Service APIs started out as a very simple API for interacting with Alexa, but as Alexa grew smarter, the API grew significantly more complicated, and it requires a lot of on-device complexity. So when we were reimagining how do we simplify these devices, what we did was we took those blue boxes and we essentially copied them over to the cloud, and we created the concept of a virtual instance that really sees these physical devices as having a long speaker and microphone wire running through IoT core to the device and to AIA on the the back end. So all of these device components in blue are essentially running in the cloud on a virtual instance that enables the device to maintain just a very small buffer and play data that we're sending down over some topics that we'll get to in a second. So again, long speaker and microphone wires down to the device is how we conceptually thought of AIA. And the implication here is that the AIS client really does become thin. And when I say it becomes thin, we've had interns write clients from full stop to fully functional in less than 2 months in a variety of different languages. So, that one. All right, so that's what we did. Why did we do it? First reason is traditional AVS devices require a number of simultaneous connections off of the device. It can get up to 4, 5, or even 6 depending on functionality that's enabled on the device. So these network connections are doing things like playing dialogue or speech from Alexa. They're playing music. They're retrieving the next alarm that's going to have to play because the customer set up a custom alarm to go off with sunrise. They're doing auth token refreshes. And there's some other ones that are there as well. But 4 is a pretty high number, we thought, because each one of those network connections was requiring buffering, a network stack because depending on which protocol is being used. We saw IoT devices as having one connection up to IoT core, and that connection being multiplexed for a variety of different use cases. One of the use cases we wanted to enable there was Alexa. So one connection off to IoT core. One codec. Rajiv already mentioned this, but if you look in the bottom right of the screen, you'll see a list of codecs that traditional AVS devices have to actually implement now. And this list is continuing to grow as we bring in new music service providers or new flash briefing content providers and things like this. And this is a pretty heavy burden for device makers to have that list of codecs that are supported on the device. What we did with AIA is, hey, if we're bringing all of these components up to the cloud, why can't we also simplify what the device needs to do to play content down to one format? Right now we do Opus. Next up is authentication. So OAuth 2 is the auth framework used by Alexa voice service products, and it's used initially for AIA products as well. But post-registration flow, the device no longer has to worry about OAuth 2, token refreshes, or things like that. We leverage IoT Core's authentication platform. If you've used IoT Core, we'll dive in a little bit more in a minute, to simplify that auth story on the device as well, and again, reduce device side complexity. And then a single speaker stream. So something AVS devices have to do right now is arbitrate, media mix, things like that. So what I mean is if I'm talking to Alexa or if Alexa's talking to me and an alarm comes in, how do I decide what plays? How do I buffer what's playing in the background, or how do I mix it appropriately depending on the rules associated with those different content streams? We figured, why does a device need to worry about that? Alexa's smart enough on the back end to know what's playing and to tell the device, hey, change your volume here. You don't have to worry about the content type. Just increase it because it's an alarm. We'll talk more about that in a second as well. So the result of all of this is significantly less compute and memory required on the device itself. So that's what we did, why we did it. How would you get started on doing this? What are the components? First thing that you need is an AWS account. So these are IoT Core devices. IoT Core authenticates its devices using X509 certs, IAM, things that you're very familiar with. And creating certificates, once you get an IoT Core account provision, will enable you to get devices provisioned, establish your fleet, get the gateway endpoint that you're going to connect your devices to. And once you get that gateway endpoint, you can actually begin implementing your devices, whatever they look like, whatever platform they're running on, to connect to that gateway. And once you do that, you have an IoT Core functional device. And you can start using all of the IoT Core features that you've already heard mentioned: device management, rules engines, messaging. So one of the ones that we wanted to enable on top of that is Alexa. You're an IoT Core customer. You're sending messages, you're doing analytics on this device. Let's put a microphone on it or a speaker on it or both, and then enable Alexa. So to do that, there's one additional prerequisite step, creating an Alexa voice service product. This is exactly the same as creating a traditional AVS product. You go to the Alexa Voice Services developer portal, you tell us what type of product you're building. Is it commercial? Is it something you're working on for yourself at home? What's the category? With one additional step. Here's my AWS IoT account that I'm going to be working with this product, this device type through. So this account is tied explicitly to that device type, and only this device type can work with that account. That's the one new step, and that's the prerequisite to actually get started with device-side implementation. And there's 3 things I wanted to talk through on device-side implementation. We're going to run through them and go deeper on each of them. But authentication, this is the customer registering. So the customer telling us who they are and saying, hey, Alexa, this is me. This is my Amazon account. This is who's going to be talking to you. Registering with AIA, which is a new step, and then actually implementing AIA. So LWA authentication, again, this is OAuth 2. This is common across all Alexa voice service products. AIA supports code-based linking. So you get your 5-digit code, you go to a second screen, enter it. Also companion app-based authentication. So both of these are supported. What's different here is that AIA only requires OAuth 2 at registration time. There's one HTTP call off of the device, post customer authenticating, that said, hey, tie this IoT core device, here's my IoT core information, to this LWA registration, and then that pairing allows AIA on the back end to interact with the device through IoT core. And what that means is that hourly OAuth 2 token refresh that has to go on for traditional AVS devices is no longer needed on these IoT core devices because they're connected and authenticated through certificates on IoT core. So that one HTTP call that I'm talking about post customer authentication also sets up a key exchange between the device and the AIA service that allows for secure communication over IoT core. So the key exchange, basically a nice secure tunnel that we'll go into a little bit more in a minute as well, and it ties that IoT core device to the customer that's interacting with Alexa. After you've done those 2 pieces, implemented those 2 components on your device, it's actually the AIA spec. So this is the API, if you will, for interacting with AIA. What you'll notice is this looks very similar to like a URI structure, a REST URI structure. Coming from the top down, you'll see $AWS/Alexa. This is the reserved topic space that Philippe mentioned, that messages go across that are not metered or charged to your account interacting with AIA. The red boxes are just JSON messages, very similar to the AVS API if you worked with that before. Very small, simple JSON messages, and those are control plane topics. So this is, events and directives coming up and down from Alexa. The blue boxes are actually what we consider our data plane. So these are, binary, for all intents and purposes, raw binary data that's either coming up from the microphone to the AIA backend or from Alexa backend down to the device itself. And then control plane is interacting with those long speaker and microphone wires. So we're going to dive deep into each of these boxes, but first I wanted to talk about the colors around the box. So you'll notice the yellow colors. This is the additional layer of encryption I mentioned on top of what AWS IoT already provides. So IoT core connections are TLS protected. We've established another layer of encryption on top of that TLS connection that moves through IoT core to the Alexa backend. And again, that's done in that one registration call post customer authentication. Additionally, how many of you have interacted with the MQTT protocol before? All right, fantastic. So we get a pretty regular question. Hey, MQTT doesn't seem like it's a great protocol for voice or audio streaming. And it's not a great protocol for it. However, it's a very workable protocol. So AWS IoT offers 2 levels of quality of service, 0 and 1. QoS 0 on IoT core is extremely fast, very low latency. So we've adopted QoS 0 for AIA. What that means, the implications of that, is that we've actually implemented something that looks like a very lightweight TCP protocol in our application layer. There's 3 components here that are interesting: sequencing, send rate limiting, and buffer management. So sequencing, As you would expect, we send our messages, and we need them to be resequenced both on the device and server side. What this implies is that you need a buffer on the device that can handle, some fixed set between 4 and 10 messages to help resequence. And that brings us to send rate. So we regulate the rate at which we send messages from the client and from the service in order to minimize, the error rate or the out-of-sequence rate for those messages. And then buffer management. We have, the concept of overflow and underflow on the device side. The server side we don't, because we have unlimited memory. But on the device itself, we expect the device to tell the service, hey, you're sending me too fast, I'm overflowing or I'm underflowing. We'll talk a little bit more about that as well. All right. So that's kind of the overview of the spec. Going into each of the boxes, so each of the topic spaces or the URIs. So connection. We understand a device might need to be connected to AWS IoT Core separate from having an Alexa connection established. You might be doing an OTA update, and you might not want your customer interacting with Alexa during that OTA update. Your customer might have opted out of Alexa engagement on that device, but still be using other smart home functionalities or other things for your smart device that you've created. So if a device connects to IoT Core and wants to connect to Alexa, we have a separate connection topic for AIA that says, hey, let's start an Alexa session. Here's my sequence. We'll set our sequence numbers to 0 on both sides. This is a session, very similar to sessions you see in other applications. And that session is robust enough to survive across, some network connection drops with IoT or the internet. So, but it's really just a session. So establish a session. It's active and usable. Once you've established that session, it's time for the device to tell Alexa what it's capable of. So if you're familiar with the Alexa Voice Services API, there's a long list of device-side capabilities, 20 plus, and it's growing. What we've done for AIA is taken that number down and said, hey, if we just treat this device as that long speaker and microphone wire, what do we need to do to support audio? There's one requirement that we have, and that's essentially you telling us, the device saying, hey, this is how big a message you can send me without overflowing my buffer with one message. So IoT Core supports 128K. We don't expect our devices to go up that high. If they can handle that much, they're probably got plenty of memory. So this is saying send me 5K max message sizes because I'll support a resequencing buffer of 8, something along those lines. Once you've established your required capabilities, we have a couple of optional ones. You might have a speaker on your device, you might have a microphone, you might have both. If you have a speaker, hey, what format of data in our binary speaker topic should we be sending you? Again, right now we support Opus, but there are some options here and some areas we can do in the future, do some different things. Microphone, alerts, how many alerts can you persist on your device? How much room have you made for a customer to enable 5 alerts, 10 alerts, 20 alerts? How much room, application level do you have on your device? Once you've established capabilities, AIA can start sending you messages over that topic space in IoT Core, and the device can start sending messages up to AIA, and it will start responding to them. Example is the speaker space. So this is the interesting one. So single codec right now is Opus, and this is binary frames from Opus being sent in MQTT messages. The device is getting those, putting them in what we expect to be a circular buffer, and our control plane is interacting, saying, hey, at this particular offset in that buffer, open the speaker, close it here. Also, the device is sending up, hey, you sent me too many messages. My buffer is full right now, slow down. And also resend some of these guys. And you'll see a couple more in a bit, but microphone is kind of the flip side of this. Hey, customer uttered Alexa or pushed a button to tap to talk. I've opened my microphone, and I'm sending you binary data on the microphone stream. The flip side of that is Alexa might need you to open the microphone for a multi-turn engagement. If you ask Alexa, what's the weather? She might come back and say, what city do you want the weather in? That's a microphone open directive. The event and directive topics, this is our control plane. This is very similar to the AVS API, where events are things coming up from the device itself. Directives are coming down from Alexa. And an example of a directive that might come down from Alexa is set attention state. Hey, I've interacted with Alexa. Alexa is now thinking. Or I've told Alexa, do not disturb me. Let's turn on the purple LED on the device itself as an attention state. Volume change, set volume. So you might have a speaker stream coming out of the device that's Alexa dialogue. That might get interrupted with an alert. A customer can set a particular volume for an alert that's different than the volume of Alexa's speech. So while you're playing that speaker stream, the device itself doesn't need to worry about what content is playing. AIA is going to say, hey, you're playing content at this offset, just raise your volume up to this level. At this offset, turn it back down. Doesn't have to worry about owning, knowing, managing state, or buffering across 4 different channels of content. AIA worries about it, understands the context of what's playing, and just tells the device what specifically needs to happen and when it needs to happen. So the full spec is at the link on the bottom. There'll be another link screen at the end, but the events and directives are the control plane. Once you've implemented those topic spaces, you have a fully functional AIA device. It's a fairly small set of APIs, and again, if you go to this link and you start comparing and contrasting to the Alexa voice service APIs, it's a pretty reduced set. So there were some breakouts that covered some of this functionality, and then also covered things like, hey, I'm connected to IoT Core, I've implemented AIA, now I can do smart home engagement. The reason we wanted to use that single IoT Core connection is because once you have that open, if you set up a smart home skill or custom skill and you want to send additional context or commands down to the device or use Thing Shadow, you have that connection open and you're already using AIA over it. You can then use some smart home stuff over it as well. So the IoT 304 talked about some of the other things you can do once you have that IoT Core device enabled and it's working with AIA. So, demo. So we have the Instinct iDevices switch here. It is a beautiful switch. The red ring, if you can see that, just means that the microphone is muted because we've been saying Alexa a lot, and this thing has great far-field pickup. So I'm going to unmute that. It's connected to my phone's Wi-Fi hotspot right now, so we'll see how we do. And I'm going to hold it up to my lapel mic. So, Alexa, joke.
How do you thank a mule for its hard work? By saying, Donkey Shane.
Everybody hear that? Alexa, turn on Instinct. Alexa, turn off Instinct. Alexa, set volume to 3. Alexa, play Baby Shark.
Baby Shark by Pink Fong on Amazon Music.
So, Alexa, stop. So, all of that going over MQTT through IoT Core on the device itself, low latency. Latency story, we are roughly equivalent to the existing traditional AVS latency. And we have some ideas and some ways we actually can optimize and improve that in the future. Not saying we'll get faster, but maybe we will. Links, so you've seen some bit.ly links through the presentation. We figured we'd dump this on a single screen for you to take a picture of, so I'm going to leave this up until I see the cameras down. Additionally, we're wrapping up. We are going to be in the hall behind this room to answer questions one-on-one if you have any for 10, 15, 20 minutes, however long y'all are here. Let's see, still see some phones up. All right. Oh. All right. Additionally, there is Alexa skill training. So once you have that IoT Core connection open, you have a device that is Alexa built in. You probably also want it to work with Alexa, like turn on that light. Here's a link that will take you through training as well as certification if you're interested in doing that. I wanted to thank Philippe and Rajiv for putting the presentation together and letting me come up here and talk about the fun technical things we solved and are enabling. And I wanted to ask the audience to please take a couple of minutes, submit the survey on your reInvent application, tell us what we didn't dive into enough, what we covered with some redundancy so that we can improve this in the future. Just a couple of minutes and we'd thoroughly appreciate that. All right, that's it.